Continuing with number 269, they are highly related. We now have the limit as x approaches infinity of 4x. I'm sorry, that's the change. The change is negative infinity of 4x over the root of x squared minus 1. Okay. Let's get this out a little bit. All the moves are exactly the same for the most part. So we should have, factoring off x, limit x approaches negative infinity, x times 4. Out here we should have the square root of x squared, square root of 1 minus 1 on x squared, equals, and we know what the square root of x squared is going to change into, not just x, magnitude x. This is the important difference. Magnitude x, same second root, 1 minus 1 on x squared on the inside. X is approaching negative infinity. All right. Now what happens? Since x is heading towards negative infinity, we are heading towards, this is left in behavior, heading towards the left of this function. So we're only dealing with negative numbers. All right? If we're only dealing with negative numbers, as we head towards negative infinity, x is inherently a negative quantity in this whole consideration. Not that's the function's domain, I'm just saying as the limit proceeds, all these x's we're thinking about are negative. If this x is negative, what does absolute value do to a negative quantity? It negates it and makes it positive. So therefore the next move will have us with a negative x in the denominator, not just x, because we have to negate that negative quantity. X is already inherently negative, and we're negating this negative quantity because of the magnitude. And the top is still the same. So when we cancel now, x's cancel, there is still a negative left over in the denominator, which we did not have in the previous problem. And so therefore the limit will be different. Only by that sign it's true. But nevertheless, it is different. So now we see that 1 on x squared, whether this is heading towards positive or negative infinity, it does not matter. The bottom's becoming very large, and so therefore the overall fraction is becoming very small. That part's heading towards 0, of course. Should feel very confident about that by now. So you have 4 over negative root of 1 minus 0. So we see it's negative 4. The left-in behavior is horizontal asymptote of negative 4. Okay? This is a pretty unusual function. You don't see different horizontal asymptotes a lot. I showed an example with tan inverse before. Right? Here's another one. Let's just draw what we found here very quickly. I think we can figure it out. This function is a little odd, but it's not that bad. Let's just see what we have here. Just think about it a little bit. For one, we know that, looking back here, you would start to think it has an x-intercept at 0, but if you think about where this radical is defined, right, x squared minus 1, if you put 0 in here, 0 minus 1 is negative. The square root of negative does not make any sense for us in dealing with real numbers here. So therefore 0 as an x-intercept is not possible. Matter of fact, it's going to turn out that from, looks like the domain of this function is going to be what? Negative infinity until negative 1 inclusive union 1 inclusive to infinity. If x is any value between negative 1 and 1, then the radical will end up evaluating a negative in here, and that's not going to work. All right? Not only that, but 1 and negative 1 are asymptotes. If you put 1 in here, you're going to get out 0. The negative 1 here, and you get out 0 for the radicand. So therefore, those are vertical asymptotes. So let's just plot those very quickly. So at 1, vertical asymptote. Negative 1, another vertical asymptote. We already know that it has a horizontal asymptote at 4, right? And I'll just label this as 4 here. This is 2. And one at negative 4. Okay. So there's our horizontal and vertical asymptotes. It's pretty easy to tell that as x heads towards negative infinity, right? Or if x is negative at all, if x is negative, that means the numerator is negative, but the radical on the bottom can only produce positives. So therefore, as long as x is negative, meaning as long as x is on this part of the domain, the overall function value has to be negative because the numerator will be negative, but the bottom cannot be. So therefore, if it has to be negative, then it should be looking something like heading towards negative 4 here, right? And the approach from the left heading towards negative 4, and heading down towards its asymptote there at negative 1. And so to up here, if x is any positive number, right, if it's this part of the domain from 1 to infinity, then the numerator will be positive, and of course the radical will only produce a positive, and so therefore the overall function is positive. So to maintain its positivity and actually approach these asymptotes, it would have to look something like this. Okay. So there's our picture. Again, we see the right end behavior is horizontal asymptote at y equals 4, and the left end behavior is a horizontal asymptote at y equals negative 4.